Hello everyone, I am Mohammed Salik from Tenkasi. I am currently pursuing my third year undergraduate course in Electronics and Communication Engineering at Sardaraja College of Engineering, and this is my project done during the internship offered by EMERTXE Private Limited, and the title of the project is IoT based home automation system. Okay, let us see about the project. First, we are going to see about the introduction and what is IoT, what is home automation, and then embedded systems, architecture of IoT, project purpose, required components and software, project requirement, user interface, and then at last conclusion. First, we are going to see about the Internet of Things. The Internet of Things describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with the other devices and systems over the Internet. Embedded systems. An embedded system is a microprocessor based computer hardware system with a software that is designed to perform a dedicated function either as an independent system or as a part of a large system. And then programming. We are done the programming by using the embedded C language. Embedded C is nothing but the extension of C programming language. It is generally utilized for creating microcontroller based applications. Talking about the extension, it is fixed point arithmetic operations, hardware addressing, accessing address spaces, and more. During our internship period, we are learned some basics of C language, which is required to do our project. And benefits of embedded C language over other languages. It executes a similar task continually, so there is no requirement for changing hardware like additional memory or storage space. It performs nearly a single task at once. The cost of the hardware used in embedded C is typically so much low. It takes less time to develop an application program. Embedded C can run predefined programming. It is effortless to understand. Okay, and then what is home automation? Home automation refers to the automatic and electronic control of household features, activity, and appliances. In simple terms, it means you can easily control the utilities and features of your home via the internet to make life more convenient and secure, and even spend less on household bill. And then benefits of a home automation system: managing all of your home devices from one place. The convenience factor here is enormous. Flexibility for new devices and appliances, maximizing home security, remote control of home functions, increased energy efficiency. And then the architecture of IoT. The architecture of IoT contains four main blocks: smart things, and then networks and gateways, middleware, and then applications. Okay. Then purpose of a project. The aim of a project is to design and construct a home automation system that will remotely switch on or off any household appliances connected to the internet using a microcontroller or voice-based command or Bluetooth-based Android application. Okay, let us see the components required for our project. First, Arduino Uno, that is nothing but a microcontroller board, and Ethernet module and PCF8574. This is nothing but a remote I/O expansion for microcontroller, temperature sensor, LCD HD44780. This is to display our values in the LCD display, and then the LDS sensor. First, we are going to see about the Arduino Uno. Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins, of which 6 can be used as pulse width modulation outputs, and 6 analog inputs as 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. Okay, and then Ethernet module. W5500 chip is a hardware TCP/IP embedded Ethernet controller that enables easier internet connection for embedded system using SPI (Serial Peripheral Interface). It user in need of stable internet connectivity best using a single chip to implement a TCP/IP stack 10 by 100 Ethernet MAC and PHY. Hardware TCP/IP stack supports TCP, UDP, IPv4, ICMP, ARP, IGMP, and PPoE. Okay, and then PCF 8574. This is nothing but a remote expansion. And temperature sensor. In our project, we have used the LM35 as our temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. The LM35 is one kind of commonly used temperature sensor that can be used to measure temperature with an electrical output comparative to the temperature in degrees Celsius. and then the LCD HD44780. The Hitachi HD44780 LCD controller is the LCD used in our project. It is an alphanumeric dot matrix liquid crystal display controller developed by Hitachi in 1980s. The character set of the controller includes ASCII characters, Japanese kana characters, and some symbols in two character lines of 28 characters. And then LDO sensor. The LDO sensor is nothing but the light dependent resistors or light sensitive devices most often used to indicate the presence or absence of a light source or to measure the light intensity. LDO sensors are also known as photoresistors. The working principle of an LDO sensor is photoconductivity, which is nothing but an optical phenomenon. When the light is absorbed by the material, then the conductivity of the material enhances. If the light falls on the LDR, then the electrons in the valence band of the material are eager to the conduction band. Okay, let us see about the required softwares and tools for our project. First, we need Arduino IDE. This is nothing but an open source development environment. And then PixSimLab, then Blink mobile application. It is nothing but a mobile IoT application, and then null emulator for virtual port emulator. First, Arduino IDE. The Arduino Integrated Development Environment or Arduino Software IDE contains a text editor for writing code, a message area, a text console, and a toolbar with buttons for common functions and series of menus. It connects to the Arduino hardware to upload programs and communicate with them. And then PixSimLab. This is nothing but a simulating tool. PixSimLab is a real-time emulator of development boards with integrated MPLabX or AVR GDB debugger. PixSimLab have integration with the MPLabX Arduino IDE for programming the boards or microcontrollers. And then Blink IoT application. Blink is an IoT platform for iOS or Android smartphones that is used to control Arduino, Raspberry Pi and Node MCU via the internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widgets. Okay. Let us see a very project requirement. In our project, we have three main requirements. The first one is garden light controls. To control the garden lights, in order of sunlight, and to control the temperature control the temperature, and then the water tank inlet and outlet valve control. Let us see some snapshots of our project. This is our garden lights control, and this is the second requirement, temperature control system. This is our mobile IoT Blink app interface with the CLCD display and our temperature system. We can see later in the demo session. And then serial tank control system. Okay. Let us see about the Arduino IDE. This is our Arduino IDE for writing code and uploading code. Using this using this uh, using this menu, we can upload our code in our microcontroller board. And using this menu, we can compile our code and check if there any warning or any error message is exists. And this is our text editor. In here we can write our code or modify our code. Okay, this is our error console. If there is any error in our code, that will appears in here, and other messages are shown here. Okay, this is our temperature. This is our declaration of our temperature system, and this is the declaration of our garden light system. Okay, now let us see about the project demo. Okay, first, this is our PixSimLab. This is nothing but a simulating tool. In our project, we do not using a actual Arduino Uno. Instead of actual Arduino Uno, we have used the simulated board. Okay, this is the reset button, and this is the this is the connector, USB connector. That's all. And this is the final setup of our project. I will explain. one by one. This is the CLCD display for displaying the temperature value and the volume of the water present in the water tank. And this is nothing but the LEDs which are used as the garden lights. And this is LDR system. This is Ethernet module. This using by using this Ethernet module, we can connect the we can connect the Arduino Uno with the internet, and this is the temperature system. It contains a heater, a cooler, and extra stuff. Okay, let us see the demo first. Okay, first First, we are going to see about the first requirement of our project. This is nothing but the garden light system. This is our LED used as the garden lights, and this is the LDR system. The LDR system works. Okay, first we are going to see about the garden light control. The LDR, as per the definition, the LDR system works by using the photo resistance. As per the light intensity increases, the resistance of the lights are decreasing. This is the intensity of, let us assume this is the intensity of the solar light. In here, first I am going to decrease the intensity of solar light, then the garden light gets started, and when the intensity of the solar light increases, the resistance of the light is increased and the lights get off. Okay, and then next we are going to see about the second requirement. This is nothing but our temperature control system. Okay, this is our mobile IoT application, Blink application interface with our Arduino Uno. This is our project template. Okay, I have two tabs here. The first tab contains a cooler button, a heater button, and a temperature sensor gauge. This is nothing. These are all. The cooler button is used to control the cooler manually, and the heater button is used to control the heater. And then the temperature sensor displays the temperature level in here, and the temperature level is also displayed in the CLCD. Okay, and in here we have a notification bar. In this we are receiving some notifications. Let us see later. And then the next tab. In the next tab we have an inlet level button, outlet level button, and the volume gauge. in the volume gauge, we are able to see the volume of water present in the tank. Okay. First, first we go with the second requirement of our project, nothing but the temperature system. Okay. The requirement of a project is when the temperature is increased, when the temperature touches the threshold value, that is nothing but a 35 degrees Celsius, the heater button will turn off automatically. Okay, let us make a demo. I am on the heater, the temperature increases gradually in the CLCD and also the temperature gauge, temperature sensor gauge, and when the temperature is increasing by 35 degrees Celsius, I am getting a message that is nothing but temperature is above 35 degrees Celsius, so turning off the heater. Okay. In the CLCD, the temperature value is displayed, and when the heater is on, it shows heater on, and when the heater is getting off, it shows heater off. And when we need to control the cooler, I have just simply pressing the button and the cooler and the heater on, and the heater works, and the temperature gradually decreases. Okay. And the temperature in the CLCD and the temperature sensor gauge is same. Okay, now I am turning up the cooler. Okay, this is our second requirement. The second requirement is done successfully, and then now we are going to see about the third requirement. That is nothing but the monitoring the volume of water and controlling the inlet and outlet valves. Okay, first for that I'm gonna open the serial tank monitor. Okay. Okay. First, as per the project requirement, when the volume of the tank is below 2000 liters, the inlet valve turns automatically and fill the water. Okay. First, I will drain all the waters by controlling the outlet valve. When the outlet valve is on, the outlet valve gets started and the water is draining. Okay. And when the volume of the water decreased by 2000 liters, I have a message that is nothing but water volume is less than 2000 liters, so turning on the inlet valve. Okay, the inlet valve turns on. Okay, now the outlet now I will turn off the outlet valve. Okay, the water gets filled. Okay, the water volume in the in the volume gauge and the CLCD are same. Okay. Okay, and then when the water volume gets to filled, that is nothing but 3000 liters, the inlet valve turn off automatically, and the inlet valve can the inlet valve and outlet valve can operate it manually also. Okay, I have now I have on the outlet valve. Okay, the volume of the water decreasing, and in the serial CD I have a message outlet flow on. Okay, when the volume of the water decreased below 2000 liters, the inlet valve gets started automatically. Now see. Okay, now okay, now I'm turning on the outlet valve and seeing the water level. When the water level decreased by 2000 liters, no, when the water volume decreased by 2000 liters, the inlet valve turns on automatically. Okay, and then I turning off the outlet valve when the water level reaches the full volume. Let us see outlet flow off. Now I turned off the outlet flow. and it nearby 3000. Let it flow off automatically. Okay, this is our project. Okay, in here in a temperature control system, we have CLCD. We have CLCD. In the CLCD, we have the temperature value. We have temperature value and the status of heater or cooler. And in the second line, we have the volume of the water and the value of inlet, status of the inlet valve and the outlet valve. Okay, as per in the notification also. In the notification also. Okay, and this is our serial put tank. Okay. Thank you, MSG, for giving me this opportunity.